it goes without saying that Tim and I are in complete agreement about substance here, about what kind of theory physics should be aiming for, and about what kinds of words don't belong in the fundamental formulation of such a theory, and so on and so forth. As to whether, I don't know how to put this, and I guess this will emerge in the details we discuss later on. This phrase, the measurement problem, refers to an episode, a very prolonged episode, in thinking about the foundations of physics, that I think is really important. And in which a lot was at stake. Okay, so there's a distinction between figuring out what words you want to use in a proper formulation, in a proper mature formulation of a fundamental physical theory, and on that, Tim and I have been, as long as either of us can remember, in complete agreement. I think, and I endorse everything that Tim says. But if you say, I'd rather not discuss anything called the measurement problem, you're going to be leaving out an episode in which something quite enormous was at stake, and there being as much at stake as there was is one of the things that attracted me to thinking about foundations of physics in the first place. If you just call it the reality problem, if you just say, look, what we should be thinking about is what's really there, of course that's right. What's really interesting, and this emerges a little bit in the way Heisenberg was representing himself in the conversation with Einstein, what it obscures is that there was a long period in the history of physics, very much under the influence of Bohr, notwithstanding Bell's complimentary remarks about Bohr in the passage that Tim read. There was a long period when something more was at stake than just, okay, what's the proper description of the world going to end up being? Okay, something was at stake of the form, what can we hope to get from science in the first place? Does the scientific project as traditionally conceived survive our encounter with subatomic particles, and so on and so forth? So using a term like the measurement problem alludes to this period when something gigantic was at stake, not just about the output of the project, but about the nature of the project itself, about what we could hope for from the project, about what the project was entitled to aspire to, so on and so forth. That is captured by a phrase, I think, like the measurement problem. So once again, Tim's the views that Tim has just endorsed in these quotes about the appropriate place for a mature fundamental formulation of a physical theory to end up, I agree with 100%. But that agreement is, talking about something called the measurement problem evokes a debate about precisely that question. What should a physical theory look like? What can we hope for from physical theories in terms of their relationship to reality? Okay, blah blah blah, and that's and for my money, the bigger issue about the foundations of quantum mechanics was not how's it going to end up? Are there waves? Are there particles? Are there waves and particles? Blah blah blah. That's all, of course, profoundly interesting, and something that both Tim and I have spent a long time working on. But there was an even bigger question looming in the background. Is this the right way to formulate physical theories? Can we hope for physical theories which are formulable in that way? And I'm sure we'll have the opportunity to talk a lot about that over the next hour or two. But for that reason, I would very much use a phrase like the measurement problem to refer to what was at stake in a debate that I was very deeply interested in.
I mean, there's a rhetorical point, and then another point I can make very quickly. The rhetorical point is, I thought calling it the reality problem made it a much bigger problem than calling it the measurement problem, right? So
yeah, I guess I disagree with that.
I know you disagree with that, but that's not the way I hear it. And the way to illustrate that is actually sitting on Robinson's T-shirt. Okay?
What does it say?
Well, I think I have to speak to get the camera on me, but
right.
Tell Schrodinger I am live.
Right. So there was a problem illustrated famously by Schrodinger in his paper in response to the PR paper, where he brings up this cat example. And in a formal way, he talks about an experiment which involves a piece of radioactive material and a Geiger counter and a diabolical device. We all know that. Formally, that experiment is not in quantum mechanics a measurement. It's not a measurement of anything. Okay, that is, you can do experiments that are not measurements. I mean, I can give you an experimental protocol. Here's one. Take a coin, put it on your thumb, flip it so it turns at least 5 times in the air, let it land on a flat, hard floor, and record whether it comes heads or tails. That's an experimental protocol. It'll have an outcome. You can record the outcome as data. It isn't a measurement of anything. It just doesn't measure anything. If I flip the coin 1,000,000 times, maybe it'll measure a bias in the coin, but one flip is not a measure of anything. And so the problem of the cat had nothing to do with measurement, because the cat wasn't being measured. The problem with the cat was that the damn cat should end up either alive or dead, period, end of story. That's I call that in one of my papers, the problem of outcomes. You think that experiment should have an outcome, which is either a live cat or a dead cat. And if your physics doesn't give you that, then Schrodinger's view was your physics is obviously, radically, terribly inadequate, right, to describe the physical world. That's not a problem about measurements, because that experiment just isn't a measure. And so I think one needs to keep a focus on that part of it. And the term measurement brings with it other considerations that are actually kind of irrelevant if you're worried about, I want my cats to end up alive or dead. Because why? Because cats end up alive or dead. That's why.
I'm not sure this is going to be a productive road to go down, but I'm a little puzzled by what you just said, Tim. If somebody were to construe the cat experiment as concluding with a measurement of the aliveness of the cat, or if somebody were to construe the coin flip experiment as concluding with the measurement of the orientation of the coin, would they be severely distorting the situation somehow?
It would be severely misrepresenting the experiment.
What? So I guess yes, but
normal experiments, it has a setup situation and then a result situation, and the experiment is the entire process from beginning to end. Now, you may want to say that, the end of it is yet another measurement of something, although, try and write down a Hermitian operator for the aliveness or deadness of a cat. Good luck with that.
But that'd be hard to do, but we don't have good reason for doubting that such an operator exists.
Sure we do. I think we have every...
What do you have in mind?
Now we're going to get into technical stuff about what there's good reason to believe they're Hermitian operators for, what there's good reason to believe they're positive operator valued measures for. We could, arrival time experiments that have outcomes.
Let's keep away from that.
Right. A whole technical thing we could devolve into, which is actually extremely important, but not, I think, at the level we want this podcast to be. I just think if you think the problem is illustrated by Schrodinger's cat, there's just not any reasonable sense in which that setup measures that whole setup from beginning to end, right? You put the cat in the box. It's alive at the beginning. The point of that setup is not to measure anything about the cat. Right? The point is the setup either kills the cat or it doesn't kill the cat. Right? That was Schrodinger's point.
Like I say, this is going to carry us too far afield. Maybe you and I should chat about this sometime, but I'm not sure in either of those cases why it would be a crazy distortion of the situation to describe those procedures as a preparation and a measurement, as a preparation followed by a measurement in the usual laboratory way. But look, let's. Maybe it's not going to be productive for us to go there.
One final point. Let's at least acknowledge that some ways of understanding quantum mechanics just have it that you start with one cat, you end with one cat, and that single cat is either alive or dead, and that's just a physical fact. And that's sort of the way we think the world is. And of course, there are the many worldsy kind of approaches which deny that and say something like you start with one cat and you end up with infinitely many cats, one of which is alive and many of which are dead in different ways. Mm-hmm. And that is certainly not the way we think the world is. And you're going to have to do some pretty severe mental gymnastics to turn such a theory into a theory we can connect up with the world as we think it is. And I think you can say all that without talking about measurement. You're just talking about cats. That's all.
Yeah, I think you could say it without talking about measurement. Yes.